So let's get started. And, the second part starts with this super exciting and innovative talk. Microminds, event-driven services modeled as neural synaptic networks. So the topic is quite kind of promising. So to be honest, I don't know what to expect, but I'm pretty sure it will be quite fascinating. And I want to welcome our beloved speaker and also permanent Devoxx Ukraine speaker, um, developer advocated Lightband's Hugh McKee.
Thank you
Welcome,
so
Hugh.
much. Yeah, thank you. It's a delight to be here. I wish with all my heart I could be with you all live. Hopefully soon we'll be able to do that. It's always a pleasure
Likewise,
to to speak with everybody.
likewise.
Yeah. So
Hopefully
yeah.
next year. Hopefully next year,
Oh,
Hugh,
with
we
that.
will be able to do offline.
Yeah, that would be fantastic. So thank you for the introduction. I'm glad you're intrigued by the the title, and I think I like going into a talk where you don't know what to expect, but it's piqued your interest. That's probably the best way to go. So, that, given that the title contains neurosynaptic network and event driven, as you can imagine, this talk is inspired by all the things that are going on with AI. And I looked at the agenda for this conference, and there's quite a few talks that are AI related, which is really exciting. And I'm just super excited about what's happening in this space right now. But I want to dive into a particular area of where it's having an impact. And I think one area that's really something I've been working on quite heavily for the last year is in this event-driven types of applications. And as I was getting deeper into it, I was starting to realize that there was kind of a connection here. So, AI is just exploded on the scene, and we're just getting started. And I think that we're kind of at the end of an era and the beginning of another big era. So I think this is a very significant moment for humanity, basically, but certainly for us in IT. So I wanted to just kind of jump right in. What do I mean by micromind services? And just start with an introduction. So first, I want to say what it's not, which is it's not AI or machine learning. But what I'm talking about is building applications that are hardwired. And the hardwiring in biological neural networks, for example, our brains, the brains of animals and insects and so on, that we all share kind of mechanically this fascinating neural network type of brain. And a significant part of that brain is the wiring, which gives kind of our instinctive innate behavior. And this is what we build with software systems, that we're basically building in the behavior of the system, and it's hardwired. So again, I'm going to show you some things that I hope will be intriguing to you that are like the behavior of instinctive minds. But the motivation for this is event driven, and I'm delighted to see that the popularity of event driven seems to be going up, in particular for building back end systems. I'm a super fan of this, and like I say, I've been doing some things with it for over the last year right now that I'm really just having a lot of fun with. I think it's a fascinating, fun, intriguing way of building backend applications. But I'm also going to be talking about what I kind of label as pure event driven. So, and I'll try and dig into that as we go through the presentation. So what I mean by event driven, so this is a design diagram that I did for a demo application. I'm a developer advocate, so I don't have to write production code anymore. I wrote production code for, I've been a professional developer for 47 years. So I've been writing software for a long time. I've written a lot of production code. And now I get to write demo code, and fun demo code. But anyways, I wanted to have kind of a non-trivial demo application. So I'll go into this in more detail. But right now, I just want to share this is an event-driven application. What I was trying to convey in this design diagram was that something comes into one of these diagonal boxes, which really represents an event-driven type of a microservice. So this A command comes into this microservice, it lights up, it processes the command, and one of the things it does is it emits events. And those events could be interesting to downstream services. So that's exactly what's happening in this application. That first one emitted an event was of interest to the second one here. This one emits events that are of interest to other services. So there's this cascading kind of sequence of events that occurs that I think is really a powerful way to build applications. And this is this isn't pretend. These are real design features of this application. I was trying to visualize the behavior of this application as it's actually written in software. This is the behavior of this application, is these event-driven types of flows. Now, in the diagram, there's three shapes. So I described the diagonal box. It's called an entity, but you can also think of it as a very focused microservice. And then that's for writing. This is for making state changes. These entities, these focused microservices. Down below are these V-shaped boxes, and they represent views. And this is for reading. And this is the whole CQRS pattern, command query responsibility segregation. Commands are handled in one place, and these microservice entities, reading or queries are handled in another place in these views. And then a third component here is up at the top. There's these little diamond-shaped things, and these are actions. These are functions that are subscribing to the events coming from upstream entities. And when those events are fired and sent to these action, they're basically serverless, stateless functions. But these functions get the events, and they transform the events into commands, which they fire off down to downstream services. And this is the flow. And this is what struck me as I was kind of getting really deeper into designing applications and thinking through the design process and the implementation of these applications. And that I'm also kind of an amateur fan of, just studying things about how biological neural networks work, how our brain works, and things like that. I find it to be a fascinating topic. And there's tons of videos and really interesting material available on how neurons work, how synapses work, and things like that. And what struck me was I'm doing this design, and I felt like, wait a minute, this is somewhat similar to the way natural biological networks work. In your brain, signals come in, signals come into a synapse and then are wired into a neuron. The neuron keeps getting signals, and at some point that neuron fires and it emits a signal that can go to a bunch of other neurons through the synapses. And there's these cascading signals that flow through your brain, and that's how our brains work. And essentially that's how neural networks work as well, for things like the large language models and so on. But what really I thought was kind of cool and gave me the impression that this was kind of going in the right direction, is that there was this kind of symmetry in the design and behavior of natural biological neural networks, which are the result, if you think about it, they're the result of a million or years or more of evolutionary iterative development. And now we're starting to mimic these kinds of patterns in event-driven types of systems. And I thought, okay, maybe we're on the right track here. So this is the behavior. These commands come in, it fires a change. The change goes out as the signal goes out as events, and those events can be then subscribed to downstream things that just do all the processing flow. This is the basic behavior of the micromind. So I want to show you, hopefully this works well, a little movie of this in action. So this is the one shopping cart just got created. And what happens in this application is stocks getting allocated to the shopping cart. So the stocks over on the right, the shopping carts are kind of coming in from the left. Now what's just happening here is this is real activity that I pulled from logs, and I wrote some code that created this movie. So the dots represent entity states, and there's all kinds of different entities that are appearing. The lines represent events coming out of one entity and getting transformed into commands going to other entities. So these are real events, triggering real commands in real sequence here. This is the demo application running for real. And you can see things like the color change indicates the state of the orders. The orders are yellow when they're being processed. They're red when they go into a back order state. And then they turn green when the orders are fully stocked and ready to be shipped. That's what this demo does. And I wanted to visualize this in a way that, kind of conveyed the behavior, which also, I think, shows you that this kind of looks like like an insect brain. If you've seen there's some really cool videos of that have been done like this, of say insect brains, which aren't super complicated like a human brain, but they've mapped them out like this, and they actually show videos like this that show the behavior of the system. So hopefully that helps you to appreciate what's going on in the system. So another thing that's really interesting is these patterns, these service design patterns started to emerge. And also I wanted to go into how this plays in with things like AI programming assistance. So the patterns, there's a bunch of different, what I'm calling kind of event-driven patterns, things I hadn't seen before in the ways I traditionally built, back-end Java applitions with databases and all that kind of stuff. And I've done a ton of that type of stuff over the years, but I didn't see that kind of thing on these patterns, for example, like this to kind of jump off the page at me, really, until I started doing these event-driven types of applications. So a big one I want to start with is, I think pretty much everybody's heard of the Saga, but I've heard of Saga for a long time, the Saga pattern. But what I didn't know was that there's actually two flavors of the Saga pattern. There's the orchestration Saga pattern, and that's where there's some kind of controller, like a workflow controller, that's controlling the steps within a Saga pattern. But a different one, which I think is very interesting, and I'm finding to be highly useful, is called the choreography Saga pattern. And that is where there's no controller. So the flow of events I was showing you in this design pattern, from service to service to service, that's a choreography Saga pattern. There's compensating actions and everything built into the design of this application, and all these behaviors are built into it, and was able to do some really powerful things with it. But there's other patterns as well. And this one is, I call one-to-many. And what's happening here is that an event comes out, say, and that event contains a list, like a shopping cart has a list of items in the shopping cart. So what happens often, and this is just a repeated pattern, you can see that there's like 5 of these one-to-many actions in this design, where it's getting that list. And so one event comes in, but it emits n number of commands to n number of downstream services. Very, very common pattern. Another one is generation loop, where events are feeding back into the same service to keep it running until it's finished some work. There's 2 of those kind of patterns in this design. A big one is what I'm calling a reduction tree. And I wish I had time to go into what a reduction tree is, but the word reduction should be a clue, and a tree should be a clue. But anyways, the 13 services here, 3 of the services are reduction trees. And that just really blew me away when I kind of first stumbled onto it, to be honest, doing a kind of this reduction tree type of pattern. And then all of a sudden seeing that in other designs and in this design, that it was useful in many different circumstances. So I want to show you a little bit of code, and I haven't explained what I've been using to do this. I'll tell you about that at the very end. But this is some Java code, and you can see there's an annotation, subscribe to an event source entity. So this is an action that's subscribing to the event stream coming from some upstream service, and the upstream service is called generator entity. So that's it. You just define the subscribe. But down here on line 8, you can see that there's an on method, and this is where the event comes in. And then that event is a one-to-many. So it's, it gets the list out of the event, just streams over it, maps the list entries into commands, and then those commands are mapped into calls, and then it just collects all those calls up because they come back as futures into a list, and then just do a wait for all the calls to complete before this action responds as, yep, I did all the calls you asked me to do, everything's fine, and it gives it an acknowledgement back. But I'm going to flip to another action. I'm going to show you, I'm just kind of flipping back and forth here. Hopefully it shows up. But you can see it's a pattern here. The code is basically the same. It's just a different set of events, but this processing pattern is the same. And these patterns in code, which I'm trying to highlight here a little bit, because this is something that these AI code assistants really like, which is where I'm heading next, AI programming assistants. So I've been using GitHub Copilot since it came out over a year ago, and it's mind-blowing. And I've been using it to do this event-driven type of code. And so the code I've been writing, there's not a lot of examples out there. It's not like the GitHub Copilot had hundreds or thousands of GitHub repos that it could scan to learn how to write the event-driven type of code I'm writing, and using the software development kit that I'm writing. Probably never saw it before. But right away, it picks up on my style for writing the code. And it's not like it's just writing a little bit of code. It writes whole blocks of code. It's just amazing. But these patterns, I think, are also very useful to help these AI programming assistants help me, write our code faster. And I've also I've been playing around with all the different AI, the AI chat bots, whatever you want to call them. I've been using OpenAI's GPT-4 a lot. Claude came out not too long ago, and that's a really interesting AI. I think it's on par, and in some cases better than GPT-4. Google's Bard has been kind of trailing, I think, in my opinion. But they just had a big announcement this week with some pretty significant improvements. So I'm going to go back to it. But I just want to give you an example. That movie that I did, it was done with Blender. Blender is an open source 3D tool. It's an amazing tool, and I've been using it for years. I did the design diagrams using Blender, but I've always wanted to do an animation, and I always wanted to do it as a data-driven animation. But I was intimidated by the API of the Blender API which is in Python. I know how to code in Python, but this API was big, and I just didn't have the time to really invest into learning how to use the API and kind of tediously go through and put something together. So I used ChatGPT 4 as my coding assistant, and I just went into GPT-4 and I said, hey, I need this Python function to do this Blender operation. And it would give me the function back. I put it in my code, see if it worked okay. If it didn't work, I go back and maybe say, hey, it didn't work or whatever, and go back. But the end result was I wrote all the code. Is about 600 or 700 lines of Python code to scan the log file data and render it into that movie that I just showed you in a couple of days. And just amazing, just amazing. It's something that I always hesitated to do. I finally was able to kind of push myself through it and just get it done really, really fast using something like GPT-4. I've also been using Claude to experiment with creating code as well, and there's some pretty crazy things that you can do with that. Another tool that caught my eye, this one came out a few months ago, and it got a lot of attention initially. I think it's cooled off a little bit, but I think it's a very interesting tool. It's called GPT Engineer, and there's more tools like this coming out. And this one, the QR code is for a link to the GitHub repo for this project. It's not a lot of code, and what it's doing is it's using the GPT OpenAI API to talk to the AI through an API. So, anyways, it's an interesting way of creating code, and so I think this is very, very intriguing, which leads me to something else I'll talk to a little bit later about where things are going. So I want to kind of, this demo I was showing you, I call it Earthship, because what the demo does is it started out as a classic shopping cart demo, so you but implemented using this event driven tool set. And so, you can add items to a shopping cart and do all that kind of stuff. And then you can do a checkout. And when a checkout occurs, the shopping cart service entity/entity emits an event which says, order checked out. That order checked out goes to an action, and that action goes, okay, I need to send a create order command to the order service, to the order entity. And that's what's happened here. But that got boring really, really fast as far as a demo and everything. So I like to try and make demos that are visually interesting. So what I did was I've done other demos that use this kind of map UI where you could do things on a map. So in this case, what I did was you could zoom into any location on the map of the Earth, and you could, through just a few clicks and mouse gestures, pick a location, pick a circular area, and then specify how many orders you want to create in that area, like randomly generated orders, and what rate do you want to create those orders, and then unleash that onto the system. So in the movie, when you saw all those orders coming in, that's what happened. I went to this UI and I said, create a couple hundred orders. That's what the movie is, creating a couple hundred orders. So that's what's happening here. The highlighted line is at the top left-hand corner of the screen, sends in a single HTTP request to this one service that I call generator, appropriate name, because it's going to trigger the cascading sequence of events to generate orders. Now, this application can generate hundreds of orders. It can generate thousands of orders. It can put a serious heavy load on the application, which is also one of my intentions of this demo, was to really generate some traffic to do a couple things. One is I wanted to make sure my design could stand up to high concurrency and high load and those types of things. But I also wanted to make sure the platform that this application was running on, how fast can it run? What's its performance characteristics? So that single HTTP request came in, and that movie, what you saw, which created about 10,000 entity instances. Each of those dots, there's about 10,000 dots that created in the movie, and there's about 15,000 lines that got created in the movie. So a lot of activity got created by one single HTTP request. That's a massive cascading sequence of events. So the order comes in and it goes to a geo order. Where geo order just is an order at a certain location in latitude and longitude on a map, and then that finally creates an order. Now that what this application does is it's allocating stock to the order. So the order gets kind of broken down from the order to the order items to the actual physical units of stock. And then this starts kind of an exchange between the stock that is required for an order and the inventory or the stock that's in the system. So this system is this is where the system is allocating stock to the order. It's all being done with simple commands, simple state changes. Each entity here is a simple state. It's not like a compound state. And the point I want to make is that when you're allocating stock to an order, traditionally we would do that in a nice database transaction. We'd get some order tables, we'd get some stock tables, we make our changes, we update or create whatever we need to in the database, and then we commit. In this system, it doesn't behave that way. It's actually kind of I call it a series of mutually agreeable state changes that occur. That's how stock is getting allocated to this system. But what that means, though, is that this is pure event-driven. Each of these services only emit events. Your data is only events and journals. That's the real data. The reference data is the queryable data is in the views, but that's reference data. It's not the statement of record. So anyways, a very interesting, different way of building systems that I had to wrap my head around to learn how to do it. Wasn't that bad, but it's a really interesting, different way of looking at how to build systems. So this is the behavior of this demo application. Is it's going through, and again, I'm not really explaining what's happening as each of these lines go through, but like in a workshop or something like that, I would dive into, this, and we go back and forth between the code and what's happening here. But each line getting highlighted, each service getting highlighted here is an actual real thing that this application is doing as it's doing its work. So just really quickly, what's happening here is that when a order goes looking for stock, it's also, this system also handles when there is no available stock. So the order goes into a back order state. The line going from the bottom this to the top here is a signal to that we have back orders. These back orders get aggregated into what's the back order count for a particular product. Product knows now that there's back orders. When it emits an event and says, hey, we're out of stock for product 1, 2, 3, 4, 5, whatever the product ID is. That event goes to create a stock order. The stock order gets created. Again, this is a demo system. I don't have to deal with reality here, but the stock order gets created. It creates stock, and now the stock goes hunting for back ordered orders, and it says, hey, I got stock for you, and it starts fulfilling back ordered orders. So this is the behavior of this system in 13 relatively simple microservices. Many of them, like I said, are doing common patterns. Again, this blows me away when I'm able to build systems like, that have this really interesting behavioral characteristics in it. It was relative ease, I would say, that the simplicity is really amazing. And really the focus is on the design. That's the fun part that I'm finding here, is the designing of the system. So I call this demo Earthship. This is the QR code to the repo for that demo. I'm actually getting ready to do kind of a bit of a redesign. I've already done the redesign, but some code changes to tighten it up and hopefully improve the performance somewhat, make it more efficient. But in any case, the demo's there. So this is how this demo works. Just using these 3 fundamental building blocks, entities, actions, views. It's like Lego blocks. If you've ever seen Lego blocks, it's like, what can you do with it? So here's a little bit more source code. I wanted to show you an example of the patterns within an entity. So this entity is the shipping order entity. And you can see there's some annotations at the top that are required, that specifies the ID, what is the primary key for these entities. These entities have to have what's called an entity ID, which essentially is the primary key. There's an annotation to define a type. And this is really defining the journal that all the events that this entity emits will go into. And then you can see, if you're a Spring developer, you can see some familiar annotations. These are Spring annotations for defining the API of this service. So down below, for example, here on line 185, it's doing a put on a create. The thing I want to show you here, though, is down here in 102, and the line numbers are in reverse. I use Vim, so that's why it's kind of a weird line numbering, but and it's relative line numbering, but anyways, so that you can see there's a return effects, and this is inherited from the base class of this class. Emit event, and then I call current state, which is an inherited method, and then this is my method. I'm just saying, create the event for this command. So this is going to emit an event. So this is as close in this SDK as you get to the database. There's no database connection. There's no transactions. It's pure event driven. All this code is doing is emitting events, and then it's doing a reply. And you can see you can see the patterns here. The same pattern. Darn it! I keep hitting the emit event on 101, and then emit event on line 93. They're basically just a variation on a theme. And then there's event handlers, but the same thing here. It's the current state on event. And what's happening here is the emit event persists the event to the journal. And once the event is successfully persisted to the journal, the framework calls these event handler methods. but you can see it's fairly repetitive. I just use these overloaded on methods on all these different events. It's just, they trigger a state change because you can see these event handler methods return the altered state of this, whatever this thing is. And then the state in this way, in this entity, I like records to do it. I love records. It's one of the best inventions of Java in a long, long time. And I like them mainly because they're immutable, but they're great. And so anyways, it's a great way to represent the state. So you can see at the top of the page here, some of the attributes of this state. It's got a list of order items in it, real simple. But then down below, you can see the event methods, the event for method, and the create command, and it just returns an event. That's what's happening here. There's also events plural for, and in this case, it's returning multiple events. It's returning a list of events because some commands can generate no events. Some commands can generate one event. Some commands can generate multiple events. So that's what's happening here. And then so some other event fors. So it's a pattern, just this nice pattern, and the AIs love this. Most of this code was written by Copilot. And then finally, the on methods, and these are in the state, and it's just what you're doing is for every event, that event triggers the state changes. So this is really where the business logic resides. And for the most part, the business logic of these things are quite simple. But I've kind of fallen into, this is my style. Other developers use a different style, but I fell into this style not only because I felt it was clean and a consistent pattern, and I was pushing all the business logic into the state and kind of in one place, not kind of spreading it out through the entire class, but it seemed to facilitate using the AI as well. The AI could handle it. So really what I do is I work backwards. I create the class and I kind of frame it out. But the first thing I do is I define all the commands and the events. And you can see these are just records as well, Java records as well. So command and the associated event, command and a couple events, and so on. Then I start going backwards into the state and I start writing the on methods. And it amazes me in many cases, like I said, I start typing, I'll say state on, and it will know that if I just wrote the create shipping order event on method, when I go to do the next on method, to go, oh, you want to do it for the ready to ship order event? It's like, dude, you're in my head. It's amazing. So this is kind of prompt programming in a way. I'm writing code in a way that facilitates using the AI. So this is the micromind. This thinking of event-driven as your services are kind of like neurons, and the connections, the wiring between the services is kind of like the synapses taking events and transforming them into commands. It's a very powerful programming pattern. So I just want to wrap up quickly with a couple things here. We've been talking about microservices for a long time and like best practices for microservices, and they really apply here. Microservices, I think, are like neurons in that they're simple by design. They're very focused. They do one thing and do it well. We've been talking about this forever with microservices, and it's not necessarily been listened to by many developers because in many cases, I think microservices are written as mini monoliths, not as real like microservices. Commands come in, and their request to alter the state amidst events go out, and their statements of historical facts of change, events that have occurred that change the state of an entity. These actions are like synapses. They consume events and they transform them into commands. But another significant thing that I haven't talked about before, but is all the messaging that occurs here, the events getting emitted and subscribers are consuming those events to do downstream activities. The messaging in this system is at least once delivery, which means that the messages are guaranteed. When you emit an event and you write an action, subscribes to that event, it will get that event at some point. Might not get it right away, because, depending on performance, how busy the system is, or if something's broken. But at some point, that message will get delivered. but it comes at the realization that your consumers of those events need to be idempotent because they could get the message more than once. They could get a command more than once. And that will significantly, um, I think, it alter how you approach the design of these types of event-driven systems. But I can tell you from my own experience, you get used to it. You know how to deal with it. There's these patterns of behavior that make it easy to handle these types of things. And boom, you're off and running. And now all of a sudden, you're idempotent. Doing things in an idempotent way isn't a problem. So in fact, what I do now, like in unit tests, this is a unit test for one of the services. I'm not going to bore you with the details. It comes in and kind of sets up a test and sends in a command, and then it looks at the events that came out of that test to make sure the events are correct, and then checks the state of the entity to make sure the state is correct. But then I'll also do at the very bottom here, I'll send in a duplicate command. I got the entity into a certain state, and then I send that same command again. And I want to make sure that the state didn't get corrupted, and I also want to make sure that, in this case, I don't want any events to come out when a duplicate command was received. So I just verifying that my design and implementation of this particular entity is idempotent for this particular command. So that's the approach I use. Another thing we've been saying for a long time with microservices is that each service should own its own data. And a big one here, I think, is this is what I really like about event-driven types of applications, is that there's this kind of let it crash mentality that any part of this system in this long cascading sequence of event processing flows, any part of this could fail, go offline for a while, and get restarted and come back up. And the system will simply pick up where it left off and resume. No data gets lost, no messages get lost. All that very strong, robust capability is built into the system. So finally, just a quick look into the future. And it just so happens I watched a video this morning of somebody else doing something exactly what I'm talking about here. And I'm just calling it test-driven prompt programming. The idea is that the prompts are the new source code. Not the code that gets generated by the prompts, but the prompts are the source code. We actually save our prompts as source code, and that's the design and the implementation of our applications. This is a radically different way of thinking about how to write software systems. It could, it will generate some kind of code, but the generated code is kind of like the way we treat machine code. We don't look at the assembly language that's generated or the bytecode or all the stuff that gets generated during the compilation step that we just don't look at it. It's not part of what we do. We're kind of at this higher level of abstraction in whatever programming language you're using. What I'm saying here is what's starting to happen is that we're moving up another level, that now these become the legacy languages. The Java, JavaScript, TypeScript, Python, Scala, Kotlin, they become the new machine code. They become the COBOL. I think this is where we're heading very, very quickly. So I think microminds are ideal for AI programming assistants because of the simplicity of the software components and the simplicity of the actual code within those software components. I think this, it just follows that kind of elegance and simplicity that natural biological neural networks have, but do very, very powerful things like, how we live, using our brains. They're simple components. They're simple to test. And I don't know. I just think that this event-driven, this pure kind of event-driven architecture is very amazing and very powerful. Another thing I think I like about it is that it's kind of an opinionated architecture, and the goal is to make it easy to do things right and hard or difficult to do things wrong. But I know it's unfamiliar, so there is a learning curve, but I don't think it's that big of a learning curve. But there is this whole thing of dealing with idempotency that was one of the big things that I had to, as I was coming up to speed on this, had to kind of learn. And latency is another one, that with all these cascading sequence of events. So building systems that are designed to handle the natural latencies that are part of the way the processing flows work here is also important. So hopefully this was interesting, this whole concept of doing this kind of relationship between event-driven, a style of building event-driven applications that is, I think, somewhat similar to how biological neural networks work. So I want to leave you with two things. I love this statement, and it's more important today than it ever was. The illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And boy, I had to unlearn a bunch of stuff and relearn some new stuff to get into this. Again, it wasn't huge, but definitely was, this kind of a process. The other thing I'm going to say, and I think this is also extremely important, is getting more important every day, is that AI will not replace you, but people using AI will. So you have to get ahead. I'm really happy to see how many talks in this conference are AI related. It's great that this is becoming a really hot topic that we're all talking about in conferences like this. So that's it. Thank you very much. This is the QR code for the slides for this presentation, and everything I've been working on, this whole event-driven system, is from my company. It's a platform as a service is called Calyx. I just, as a developer, it's blowing me away, but I know I work for the company that has it, but I just love writing applications with it. It's a really interesting way to do things. The QR code at the bottom center is a link that'll take you into kind of getting started as a developer if you're interested in it. But the inspiration for this talk was all the work I've been doing with Calyx. So thanks so much for your time.
Cool. Thank you very much, Hugh. So that was like fascinating as I was expecting. I mean, it's it makes you to rethink some of these things, and actually this like idea of this synapses and this like event-driven architecture builds like a sequence of this synapses. I mean, it's also been. I mean, I really like it. It's been in my kind of head in my mind long time ago. I just didn't have time to kind of to do some cool demos with that or stuff like that as you shown today. But this is really cool, and I also like your phrase. I should probably use it in the panel discussion as well. Is that the AI won't replace developers, but developers who are using AI can potentially replace those who are not using AI. So this is the
So it's good news, right? I mean, all you gotta do is
sense.
jump on board and do it. I think it's a blast. I'm loving it. It's just fascinating. This is the most fascinating time I've ever seen in my whole career right now. It's just incredible. It's scary, but it's just I've never seen anything like this. It's huge. But it's a blast.
Yeah, interesting times.
Yeah,
and lots of opportunities now, even more than before.
Oh, yeah.
Okay, thank you very much, Hugh. And again, it was a pleasure to have you at the Devoxx as usual. So hopefully we'll see you like in person next year.
Excellent. Thanks so much. Bye bye.